Welcome to our lightning talk for project 20347, Hoop There It Is. We will be briefly running through a summary of our project and everything that went into making this what it was.
The sport of Quidditch is a fast-paced, full-contact, mixed-gender sport best described as a mix between rugby, European handball, and dodgeball. If you're imagining chaos, you're not far off. Quidditch can be chaotic and disorganized at first glance and is not easy to fully understand when you watch for the first time, but it gets better. There are 7 referees on the pitch during the game, each responsible for a different aspect of play. Assistant referees watch bludger play, snitch referees watch snitch play, and the head referee watches quaffle play. This is where the project stems from. Current goal detection relies on the head referee and goal referee at each end of the pitch to determine the validity of a goal. Meanwhile, goals can be scored from all manner of directions and angles from both the front and back of the hoops. This can lead to missed goals or even goals awarded for missed shots and close passes. This can lead to frequent stoppages to discuss controversial goal calls and conflict between players and referees. This detracts from the pace of the game, enjoyment of the spectators, and the referee's ability to focus on making other calls such as contact penalties, misplays, and safety or gameplay fouls.
The problem at hand is that the goal detection is primitive and leads to disputes between referees and players. A few of the different solutions discussed were single plane, double plane, and video review type verification. The video review was far too expensive to consider for the project given the budget, and we decided to use a single subplane solution for detection. The proposed solution is to add a sensor array to the hoop that, when a ball passes through, triggers an LED light that is easily visible to the referees to determine a goal. The budget for the project was $500, supplemented by the senior design office.
We constructed the hoop upright out of 2.5-inch PVC pipe and fittings. The hoop itself is made of semi-flexible PEX tubing cut down so that it has an internal diameter of 33 inches, and the base is a plywood sheet. We used Creo-parametric to construct our model, and this helped us determine the length of PEX tubing we would need in order to have our desired 33-inch diameter.
Our design was intended to offer a stronger, more durable hoop to be used during gameplay that also accomplished the main goal of offering low-cost goal detection. To this end, the hoop up and upright hardware was sized up from current models to offer more strength in the face of contact with players or balls, and further work was being done to constrain the hoop material within the T-connector. All designs considered were intended to provide this increased durability while also preserving or upgrading modularity for frequent assembly and disassembly, as well as travel by car, plane, or train.
Infrared emitters and phototransistors are assembled in a 1-to-1 array across the hoop diameter, and a square wave is produced by the infrared emitters. By comparing the voltage on the drain of the phototransistors to thresholds, the analog signal can be converted to a digital signal, conveying a blocked or clear signal, which reduces the computational intensity on the DC microcontroller. The signals to the emitter are controlled with the multiplexer to avoid noise from the surrounding emitters as well as reduce power usage. And the phototransistor outputs are selected with a multiplexer to reduce the input processing on the microcontroller. The software algorithm combines consecutive blocked sensors into a single object and uses heuristics such as the size of the object and the amount of time the object blocks the sensors to determine if it is a goal. Once the goal is determined, LEDs around the top of the hoop indicate a goal scored, and the goal is communicated using a Zigbee module.
In summary, the project came in under budget, and due to the COVID-19 pandemic, prototyping and systems testing was cut short and in some cases for our group canceled. If the project has a longer lifetime, that would mean adding a carrying case and central control hub to automatically update score.